Welcome to Act Notes Tutorials. My name is Professor Dan, and I am going to give you a quick tutorial on the verification process. What is the verification process? The verification process is part of the overall systems engineering process. It confirms that the design synthesis has resulted in a physical architecture that satisfies the system requirements. Throughout a system's life cycle, design solutions at all levels of the physical architecture are verified to meet specifications. To understand the verification process, you have to understand how it fits into verification and validation. Verification and validation are steps in the systems engineering process to determine if a system or component satisfies its operational and system-level requirements. Verification and validation requirements are established during the course of a program to provide adequate direction for system engineers to gauge the progress of a program. Verification is a quality control process that determines if a system meets its system-level requirements. Validation is a quality control process that determines if operational requirements are met for the overall system as specified in the Initial Capabilities Document and Capability Development Document. What are the objectives of the verification process? The objectives of the verification process include using established criteria to conduct verification of the physical architecture from the lowest level up to the total system to ensure that cost, schedule, and performance requirements are satisfied with acceptable levels of risk. Further objectives include generating data, to confirm that system, subsystem, and lower-level items meet their specification requirements, and validating technologies that will be used in system design solutions. A method to verify each requirement must be established and recorded during requirements analysis and functional allocation activities. What are the verification process steps? The 3 steps in the verification process include: Step 1, Planning. Step 2, Execution. And Step 3, Reporting. I will discuss each step next. Step 1 is Planning. Verification planning is performed at each level of the system under development. The following activities describe the development of a verification plan. Verification method and level assignments defines the relationships between the specified requirements method and level of verification. This activity typically yields a verification cross-reference matrix for each level of the architecture and serves as the basis for the definition of the verification tasks. Verification task definition defines all verification tasks with each task addressing one or more requirements. The ability to define good verification tasks requires the test engineer to have a sound understanding of how the system is expected to be used and its associated environments. Verification configuration definition defines the technical configuration, resources, including people, and environments needed to support a given verification task. Verification scheduling defines the schedule for the performance of the verification tasks and determines which verification tasks are in sequence or in parallel and the enabling resources required for the execution of the verification tasks. Typical verification methods. Typical verification methods use the following: Analysis, the use of mathematical modeling and analytical techniques to predict the compliance of a design to its requirements based on calculated data or data derived from lower-level component or subsystem testing. Inspection, the visual examination of the system, component, or subsystem. Demonstration, the use of system, subsystem, or component operation to show that a requirement can be achieved by the system. And finally, test, the use of system, subsystem, or component operation to obtain detailed data to verify performance or to provide sufficient information to verify performance through further analysis. Testing is the detailed quantifying method of verification it is ultimately required in order to verify the system design. Step 2, Execution. The performance of a given verification task with supporting resources. The verification task results, whether from a test, analysis, inspection or demonstration, are documented for compliance or non-compliance with data supporting the conclusion. Step 3, Reporting. Reports the compiled results of the executed verification plan and verifies the materials employed in system solutions can be used in a safe and environmentally compliant manner. Thank you for watching this tutorial on the verification process. For more information, please visit the webpage. Congratulations on finishing this tutorial and thanks for visiting Act Notes.